Hello everybody. So in this video, let's discuss about probability distribution and its types. Introduction to probability distribution. In statistics, the probability distribution gives the probability of each outcome of a random experiment or event. It provides the probabilities of different possible occurrences. Also read events in the probability here. To recall the probability is a measure of uncertainty of various phenomena. Like if you throw a dice, the probability of its outcome, if it is defined by the probability. This distribution could be defined with any random experiment whose outcome is not sure or could be predicted. Let's discuss how its definition, function, formula and its types here, along with how to create a table of probability based on random variables. What is probability distribution? Probability distribution yields the possible outcomes of any random event. It is also defined based on the underlying sample spaces as a set of possible outcomes of any random experiment. These settings could be a set of real numbers or a set of vectors or a set of any entities. It is a part of probability and statistics. Random experiments are defined as the result of an experiment whose outcome can't be predicted. Suppose if we want to toss a coin, we can't predict what outcome it will appear, either it will has a head or tail. The possible result of a random experiment is called an outcome, and the set of outcomes is called a sample point. With the help of these experiments or events, we can always create a probability pattern in the terms of variable and probabilities. A random variable as a probability distribution which defines the probability of its unknown values. Random variables can be discrete or non-constant or continuous or both. That means it takes any of an undesignated infinite or countable list of values, provides with a probability mass function feature of a random variable probability distribution, or can take any numerical value in an interval or set of intervals. Though a probability density function that is representative of the random variables probability distribution, or it can be a combination of both discrete and continuous. Two random variables with equal probability distribution can yet vary with respect to their relationship with other random variables or whether they are independent of these. The recognition of any random variable, which means the outcome of randomly choosing value or as per the variable's probability distribution function, are called in random variables. So let's discuss about types of probability distribution. There are two types of probability distribution which are used for different purpose and various types of the data generation process. The two types are normal or cumulative probability distribution, binomial or discrete probability distribution. Cumulative or normal probability distribution. The cumulative probability distribution is also known as continuous probability distribution. In this distribution, the set of possible outcomes can take on values in a continuous range. For example, set of real numbers is a continuous or normal distribution as it gives all the possible outcomes or real numbers. Similarly, a set of complex numbers, a set of prime numbers, a set of whole numbers, etc. are example of normal probability distribution. Also, in a real life scenarios, the temperature of days is an example of continuous probability distribution. Based on outcomes, we can create a distribution table. A probability density function describes this. The formula of normal probability distribution is shown as P of x is equals to 1 by nu by root of 2 pi e to the power of minus 1 by 2 by x minus mu by eta whole square. So mu is the mean value, eta is equals to standard distribution of probability. If mu is equals to 0 and standard deviation is equals to 1, then this distribution is known as to be the normal distribution. X is equals to the random variable in the normal probability distribution. Cumulative or normal probability distribution is also, since then the normal probability statistic estimates many natural events so well. It has evolved into a standard of recommendation for many probability queries. Some of the examples are height of the population of the world, rolling a dice once or multiple times to judge the intelligent quotient level of children in the competitive world, and then tossing a coin, income distribution in countries, economy among poor and rich, the sizes of female shoes, the weight of newly born babies range, the average report of students based on their performances. Binomial or discrete probability distribution. A discrete binomial probability distribution whereas the set of outcomes are discrete in nature. For example, if a dice is rolled, then all the probable outcomes are discrete and gives the mass of outcome. It is also known as the probability mass function. So the outcomes of binomial distribution consist of an n repeated trials, and the outcome may or may not be occur. Formula of binomial distribution is p of x is equals to n factorial by r factorial into n minus r factorial into p of r by 1 minus p of n to the power n minus r, and p of x is equals to c of n comma r into p of r into 1 minus p of to the power n minus r. So n is equals to the total number of events, r is equals to the total number of successful events, p is equals to the success on a single trial probability, ncr is equals to n factorial by r factorial into n minus r factorial. 1 minus p is equals to the failure probability. As we already know, binomial distribution gives the possibility of a different set of outcomes. In the real life, the concept is used for to find the number of used and unused material while manufacturing a product, to take a survey of positive and negative feedback from a people for anything, to check if a particular channel is watched by how many viewers by calculating the survey of yes or no, the number of men and women working in a company, to vote, the count the vote for a candidate in an election, and more. Probability distribution. The Poisson's probability distribution is a discrete probability distribution that represents the possibility of a given number of events happening in a fixed number of spaces. If these cases occurs with a known steady rate and individually of the time since the last event. It was titled after French mathematician Simon Dennis Poisson. The Poisson distribution can also be practiced for the number of events happening in the other particularized interval, such as distance, area of volume. Some of the real life examples are the number of patients arriving at clinic between 10 to 11 a.m., the number of emails received by a manager between office hours, the number of applies sold by shopkeeper in the time period of 12 p.m. to 4 p.m. daily. Thank you for watching this video.